Day 688 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1886. Determine whether matrix can be obtained by rotation. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given two n by n binary matrices mat and target, return true if it is possible to make mat equal to target by rotating mat in 90-degree increments, or false otherwise. Alright, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input mat equals a matrix or a 2D array, the first row being 0, 1, next row being 1, 0. Target equals a 2D array or matrix with the first row being 1, 0, second row being 0, 1. So before we continue, let's just make sure we understand this is the top row in mat, and this is the bottom row in mat. Boom. This right here is the top row in mat, and this is the bottom row in mat. Boom. Says the output is true. Explanation says we can rotate mat 90 degrees clockwise to make mat equal to target. So as you can see, if we take this matrix right here and just rotate it 90 degrees, then it will look like this target right here, which is what we want. And since that is possible, we return true. Now let's take a look at example 2 where it's not possible, and we will return false. So in this case, our input mat equals our matrix 0, 1 and 1, 1, and target equals the matrix top row being 1, 0, bottom row being 0, 1. This time the output is false. It says it is impossible to make that equal to target by rotating mat. So as you can see, this is mat right here. Boom. If we rotate it, there's no way we can rotate this to make it equal to this, because as you can see, this has a 0 right here and a 0 right here, whereas this would need to be a 0 for it to work, right? Since this is a 1, no matter how we rotate this, it's never going to equal this, so we return false. Now let's take a look at example 3 where the matrix is a little bit bigger. So in example 3, our input mat equals a 2D array of integers or matrix, first row being 0, 0, 0, middle row is 0, 1, 0, bottom row is 1, 1, 1. And target is also a 2D array of integers or a matrix with the first row being 1, 1, 1, middle row being 0, 1, 0, and the bottom row being 0, 0, 0. The output is true. It says we can rotate mat 90 degrees clockwise 2 times to make that equal to mat. To make that equal to target, sorry. So as you can see right here, this is what we're starting with. This is mat. When we rotate it once, it'll look like this right here, right? But we're not done yet, because this is still not equal to target, right? You see, this has top row is 1, 0, 0. We want the top row should be 1, 1, 1. This middle row is 1, 1, 0. Middle row should be 0, 1, 0, right? And so on. Same right here. This should be 0, 0, 0, not 1, 0, 0. So we need to rotate it one more time. Once we rotate it one more time, now we got the target that we're looking for. Top row is 1, 1, 1. Middle row is 0, 1, 0, and the bottom row is 0, 0, 0. Boom, which is what we wanted. And so since we were able to achieve that by rotating mat right here 90 degrees 2 times, the output is true. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, first thing we want to do is we want to create a mutable copy of the matrix to perform the rotations. So we'll declare a variable called current mat, and we'll set that equal to mat. Boom. And we need to create a helper function as well. So first we could just come right here and we could say private func we could call it rotate, open up the parentheses, we'll say underscore mat colon. It's going to be an in out. Then it's going to be a 2D array of integers like this, come outside of this, and we'll open up the brackets. Now the size of the square matrix, we need to get that, so we're going to say let n equal mat.count. Boom. Then we need to transpose the matrix, meaning swap rows and columns, and convert mat of I and j to mat j of I, and only iterate over upper triangle to avoid double swaps. So we'll say for I in 0 dot dot less than n. We'll open up the brackets. Sorry, this should be a 4. I don't know what that is. 4, boom. Then we're gonna say for j in I plus 1 dot dot less than n. We'll open up the brackets and we'll say let temp equal mat square bracket I square bracket j. Come underneath that, we'll say mat square bracket I square bracket j. We're gonna set that equal to mat square bracket j square bracket I. Boom. Then we'll come underneath that and we'll say mat square bracket j square bracket I. We'll set that equal to temp. Boom, just like that. Then we're going to reverse each row, and this is going to complete a 90-degree clockwise rotation. So we'll come right here and we'll say for hold on, y'all. Hold on. Let me see it. I don't know why I keep doing it. For I in 0 dot dot less than n. We're gonna open up the brackets and we're gonna say mat square bracket I. Come outside of that dot reversed. Sorry, y'all. Reverse and put the parentheses. Boom. Now, just a moment, y'all. Let me see something. Okay, boom. So now we are back in our helper function. I mean, not our helper function, our main function. And I think this should actually, right here, hold on. Let me see where this ends. Boom. This is actually, should be outside of this function. Right now I put it inside the main function. Sorry about that. That should be outside the main function. Boom. Now let's get into the main function. And for the main function, we are going to we created our mutable copy. Now we're going to try all 4 possible rotations. So 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So we're going to come right here. Let me clean this up for y'all. Boom. We'll come right here. We'll say for underscore n 0 dot dot less than 4. Boom. We're going to open up the brackets. And if the current rotated matrix matches the target, then we can return true. So we'll say if current mat equals target, boom, we can open up the brackets and we can return true. Boom. Now we're going to rotate the matrix 90 degrees clockwise. Come underneath this. I don't know why I keep messing up my 4s, y'all. Sorry, y'all. Boom. We'll come underneath this. And we're going to call rotate. So we're going to say rotate, open up the parentheses, and put the and sign because it's an in and out, right? We use in out, so we got to put the and sign. And current mat. Boom. Then if none of the rotations match the target, we can return false. So then we could just come underneath this and we could say return false. Now, boom. No, need to clean this up a little bit. Boom. Let's give it a run. Make sure it runs properly before we submit it. Ooh, where we at? Let's say expected to start the body of each 4. Just a moment, y'all. Let me see what's going on. Let me see. I don't know what this is right here. This should be 4j and I plus 1. Boom. Hopefully that did the trick. Now let's give it a run. See if that did it. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.